Let's look at this example. The time it takes to construct a widget is normally distributed with a mean of 10 minutes and a standard deviation of 2 minutes. Find the probability that it takes an individual less than 12 minutes to construct a widget. A widget is just a generic term meaning some item, and we don't know what the item is. We could have put a pencil, or we could have put some part for a motor car or something. So it's just a generic term. So in this particular case, what information are we given? Well, the random variable for this question is the thing that we're actually interested in recording, and what we're recording is the time it takes to put together a widget. So that's the number line, that's the time. Now, time we could put as t. Very typically with normal distributions, we actually put an x for everything until we adjust it to maybe, we'll see how we adjust it to something called x bar later on, or z. But whatever the question is about, even though this one is about the time, we normally start off with x. And we're told that the time to put this together is normally distributed. So this is the number line of the time. It's taking longer and longer and longer and longer and longer to put it together. Time increasing in that direction. And there you go. So this is the amount of time it takes to put together a widget. We're told the average time is 10 minutes. And we're told that the standard deviation is 2 minutes. And let's see, so 10, 11, some people it takes 11 minutes, some people it takes 12 minutes, some people it takes 12.1 minutes, some people it takes 13 minutes, some people it takes 9 minutes, different amount of time. Some people it takes 8 minutes. So this is just a number line, how long it takes people. And it's a continuous distribution, so even though some people it takes 8, some people it takes 8.1. Because it's normal, most of the people, the most frequently seen response is 10. So most people it takes 10 minutes to put it together. The mean is also 10, and the median is also 10. So remember, the mean, the median, and the mode for a normal distribution is in fact the same thing, and in this case it's 10. So we want to find out the probability that it takes less than 12 minutes. So less than 12 minutes, we need to work out this area over here. Less than 12 minutes. So unfortunately, this is not the special case of the standard normal distribution. The standard case, where we have tables for, will entail that being the mean being equal to 0 and the standard deviation being equal to 1. So how can we adjust that? Well, this is the process that we go through, and it's standard each time. We start off by saying, what do we want to find? We want to find the probability that the time it takes to produce a widget is fewer than 12 minutes. Okay, so this actually corresponds to this area in here. The probability that it takes fewer than 12 minutes is just this area in here. I'll write that out again, and I'm going to space it out a little bit so you can see the little trick I'm going to use. Looks like weirdly spaced out. So what I'm going to do to one side, I'm going to also do to the other side of the equation to keep it balanced. So from this side, I'm going to subtract the mean. And from the other side, I'm also going to subtract the mean, but because I know the actual numerical value, it's going to be 10. And then to each side, I'm going to divide by the standard deviation. So I'm going to just put sigma in here. And over here, I'm going to put 2. And that's going to become z. This was the transformation process I showed you earlier, x minus mu over sigma. X minus mu shifts the curves back to 0, and dividing by the standard deviation actually squashes them up or stretches them out so they have the same spread as the standard normal. So, and for shorthand, we're going to actually call that z. So I'm going to say z actually equals x minus the mean over the standard deviation. It's called z, it's called the z-score. And so what do we have over here? So x minus mu over sigma, for shorthand, we're going to put z, and z corresponds to the standard normal, and 12 minus 10 is 2, 2 over 2 is 1. So we've just transformed the problem from the one you see up here to this problem here. The curve should look the same. I'm going to endeavor to do the same curve. It's at least supposed to look the same. And so I'm trying to do the same curve as up above, somewhat. And how do I transform from here to here? Because I've just gone from a curve in x, or equation in x, to one in z. It's going to be z. How do I go from x to z? Well, this is how to do it using formulas. And by the way, the steps are exactly the same every time you do one of these questions. They never deviate. So basically, I take every x value, I subtract the mean, and I divide by the standard deviation. That's how I go from x to z. And the reason I'm going to go to z is because I had the tables that Gauss came up with all those hundreds of years ago. So what does the 10 become? Let's see, what does the 10 become? So what does 10 become down here? And well, x is 10 minus the mean, and we said the mean happens to be 10 over the standard deviation, which is 2. So actually that becomes 0. So that's right. The mean of this one is 10. The mean of this one is 0. That's what the transformation process does. More generally, the transformation process, you take any x value, this one in here, in this case it was 10, you subtract the mean, well, we know the mean is 10, and you divide by the standard deviation. We know the standard deviation is 2. So in the first case, I put 10 into here. 10 minus 10 is 0. And so that became 0. What does the 11 become? I should have drawn these directly below. The 11 is going to be here. So what does 11 become? Well, 11 is going to become 11 minus 10, which is 1, divided by 2. 1 divided by 2 is a half. So this 11 becomes a half. What does the 12 become down on when I transform it? That's going to be 12 minus 10 over 2. So 12 minus 10 over 2 is 2 over 2, which is 1. What does the 9 become? What does that 9 become when we get down to here? This 9, oops, what's that? Let's do it here. 9 minus 10 is negative 1 over 2. So it's going to become negative a half. So it's be negative a half. So I haven't done those exactly to scale, but that's what that becomes down here. So you can see we've had a problem. We wanted to find the probability that the time to construct a widget is less than 12 minutes. And that changed, and we had it there. And we could see it graphically here. And that we transformed that into the probability that z is less than 1. So that 12 became a 1. So what we're trying to work out down here is this area here. So it's the same area as above. We just transformed it onto that special case. And so now I can just go and use Gauss's table to solve this, because Gauss's table gives me all the answers for the z distribution. So this is very long-winded what I did, but these questions come out very quickly. But what I'm going to show you now, make you aware of, we don't actually really use the table anymore. We haven't used it for a number of years. We actually use Excel. And Excel has functions in it which work out anything you want to know for a z distribution. So z distribution, remember, is a standard normal with mean 0 and standard deviation equal to 1. And the thing with Excel and with the tables, the way they work is to the left. Remember, they work to the left. So if I've got a small z in here and I want to work out the area to the left, as I do for this question, the question I've actually got at hand right now is I want to find out that the probability is less than 1. So I put z equal to 1 in here. I can use Excel. And Excel has a function which is norm for the normal distribution dot s, and s means standard, so it's standard normal. Dist, so it's the standard normal distribution. And then it wants me to put the value in. So the value in our case, our z value, is actually going to be 1. Okay. And well, let me do it more generally. You put the z value in here, which is the z value from here, and then you put 1 or true. What does 1 or true mean? It's asking you a question, and your response is 1 or true. The question it's asking you is, do you want me to add all the area to the left of that point? And if you put 1 or true, it gives you the area to the left of that point, which is the probability. If you put false in there, or 0, yeah, it's going to give you the height, and the height is just a relative frequency, if you like. So it's not the actual probability, but we're always going to be interested for this course in putting 1 or true into here. So how about solving this problem? Could we have done it? Well, I guess we could. So if I want to find again this area in here, how do I do it? So this area is going to be norm dot s dot dist of 1, and that 1 is in here, coming from there, and then we're always going to put true in here. Okay, and that will give me the answers. Let's pop over to Excel and do that. So equals norm dot s dot dist, and z, see z is our value of z is 1, and cumulative, we're always going to put 1 or true in there. And let's see what that's going to give us as an answer. That's going to give us 84.8413. We can change that into a percentage. 84%. Can add some decimal places. So it's 84.13%. This is how we calculate it. So back to here. So the answer that we have here is 84.13%. So the probability that it takes fewer than 12 minutes, 84.13%. Now, we standardized that, and standardized just means we went through this process of changing it from X to Z. You didn't have to standardize it. There's another function in Excel, which I'll show you now. And this is how the other function works in Excel. It's very similar to the one I showed you down here, but instead of having norm.s.dist, it's just going to be norm.dist. So this S tells you that you're dealing with a special case of the standard normal where the mean is 0 and the standard deviation is 1. The one I'm going to show you up here is slightly different. It works for any normal distribution. In fact, I'm going to put my X in here. This one works for any normal distribution, not just a special case of the standard normal. And so here's the mean and the standard deviation. The standard normal, I know that this is 0 and this is 1, but this one I'm going to show you now works for anything, for any mean and standard deviation. So I'm going to put in an X in here. And remember I said Excel typically works to the left, and it does for these functions. So if I want to work out the area in here, all I use is norm.dist and in fact we're going to put our X in here. We're going to put our mean and our standard deviation, because it's not the standard normal, so we have to put whatever our mean and standard deviation are in there, and 1. And that will work for any standard, not just a standard normal, that works for anything. If you have a standard normal, you put 0 and 1 in there, it will still give you the correct answer. But this works for everything. But remember, you have to put the mean and standard deviation in there. So how does that work out for us in this one? Could we have actually solved this problem from the get-go, from up here? Could we have just solved it right from up here? And the answer is yes. I could have worked out that area by saying norm.dist X for us was 12, with the probability that it takes fewer than 12 minutes. The mean is 10. Standard deviation is 2. And we always put the 1 or the true at the end, as we've done up there. So that should give us the answer straight away in one go. So let's try that. Let's go over to Excel. So let's try equals. So this time it's going to be norm.dist. and the mean was, sorry, the x was 12, and the mean was 10, and the standard deviation was 2 and 1. So let's just recap that. So x was 12, we want to find the probability that it was less than 12 minutes. The mean was 10, the standard deviation was 2, and we're going to put 1 or true at the end. And that's giving us the same answer as we had above. And you can see, so you can do it either way. But obviously, if you actually do it this way here, it saves you a lot of time. Yeah, because you don't have to go through this entire process. Down here, you cut out this entire process of standardizing is all cut out if you just use this function up here.